la la!
Hi everyone and welcome back to another National 4 Maths lesson, where today we'll be going over the area of 2D shapes and how we go about calculating the area of various shapes. We'll be looking at how to calculate the area of squares, rectangles, triangles, parallelograms, trapeziums and kites. If you're unfamiliar with any of these shapes, you can check out the previous lesson where we discussed each of these in detail and the angles within them. So before we begin, it's worth mentioning what a 2D shape actually is, and the basic definition is it essentially has two dimensions. It's two-dimensional, and what that means is if it's drawn on paper, it's just basically flat and it only consists of a height and a width. So to give a few examples of 2D shapes, we can see here we have a circle and a square, and they're two-dimensional because the full shape can be represented on a flat piece of paper. As we can see here with a circle, it has both a height and a width, and same as the square. But on the other hand, if we see down here we have a line. Although a line can be drawn on a piece of paper, but essentially only has one dimension, it is one-dimensional. It only has either a height or a width, whatever you want to classify that as. And on the other side of the spectrum we have a 3D shape here, a three-dimensional shape, such as a box or a cube, whatever you'd like to describe this as. And what that means is it has a height, a width and a depth as well. It has three dimensions and therefore it can't be properly fully represented on a flat piece of paper, unlike the 2D shapes that we see here. Okay, so before we begin, we're going to go over what actually is an area and how we can measure it. So taking a step back, we mentioned in previous lessons what a length is and how we can measure a length. And taking this line as an example, we can measure this in, for example, meters, centimeters, foot, or any other measurement that we can quantify a one-dimensional object, such as a straight line. So let's say as an example, this line might be 8 meters long. But now if we look at a two-dimensional shape, such as a square, as we can see here, there are two dimensions that we have to account for. As we see, we have this 8 meter down here and also this one, and they're equal of course because in a square each side has the same length. And the way we calculate an area of a 2D shape is by multiplying the first dimension by a second dimension. In this case the dimensions are measured within meters, therefore the area is equal to meters multiplied by meters. And more common than not, this is normally written as meters squared in this fashion we see here, and this is just simply pronounced as meters squared or square meters, just depending on the context. And this is how most areas are often represented in problems or real life circumstances. But depending on the scale or the size of the problem, we can also have things like centimeters squared if the area is quite small, or we can have kilometers squared if the area is quite big. Again, it just depends on the scale and the size of the problem, but the important thing to remember is for two-dimensional shapes, it's always the dimension that we are using, and it's that squared. Okay, so the first 2D shape we'll be looking at measuring the area of is a square, and we looked at this a little bit on the last slide, but basically how we find the area of a square is just simply the length times the length. And if we have two things multiplied together that are equal, we can just simply say it is the length squared, because here we have the first dimension multiplied by the second dimension, and because both of them are the same length, i.e. they're equal, therefore this can be simply expressed as area equals length squared for a square. So let's have a quick example. We can see that we have given the length here equal to 8 meters, and because it's a square, this must mean that this side and that side all must equal 8 meters as well. So if we have a look at our formula, we can say that the area is equal to 8 multiplied by 8, which is the same thing as 8 squared. And because the length we were given was in meters, we know that the area is equal to 64, because 8 times 8 or 8 squared is 64, and it's measured in 64 meters squared, which is the area of this example right here. So the next shape we're looking at is a rectangle, and the formula is actually the same as a square. If we say that the area is equal to one side multiplied by the other side, but it's different in the fact that we cannot just say one of the sides squared, because in a rectangle we know that the sides are different lengths, whereas in a square they are equal. So let's say in this example here we have one side is equal to 6 meters in length and the other side is 8 meters in length. So how we calculate the area is just simply one side, so 6 multiplied by the 8, and then we can say that is equal to 48, and we know that we're dealing with meters again in the two lengths, so therefore the area is equal to 48 meters squared for this rectangle. Okay, so now we're going to have a look at triangles and calculating the area of various different types of triangles, and this is a little bit more complicated than the squares and rectangles formula, but I'm going to explain this right now. So the area of a triangle, any triangle that is equal to 1/2 times the base of the triangle and times the height of the triangle. And the base is different to what we said previously, either the width or the length of the triangle, because it's important that the base is the bottom surface that we measure for and it's perpendicular to the height, because a triangle only has 3 sides. Therefore what we classify as the base and the height is extremely important. Therefore the base is always this bottom side right here that we measure from, and the height is just the perpendicular length from that shape. So as we can see in 2 cases here, we have the base running across the bottom and the height is just the distance from the top to the bottom of the shape here. And as I said, the line is perpendicular as we touched on before, which just means that it's at right angles to the base. And the reason that this is the formula for a triangle is because, well, imagine we have this sort of rectangle shape that we see here that I've drawn in. We knew that before, that the area of a rectangle would be, in this case, the height times the base. But for our triangle that we see here, it's only half of that area. Therefore we can say that the area of any triangle is equal to half times the base, which is this bottom side, and then times the height, which is the distance from the top to the bottom of the shape and lies perpendicular to the base. Okay, so let's have a look at a few examples. We'll start with the one on the left here. So we see that the base is 3 meters and the height is 4 meters. Therefore we can say that the area, which we'll call A, is equal to 1/2 times 3 meters times by 4 meters, and what we can say is that is equal to 1/2 times, well, we know 3 times 4 is equal to 12, and if we have a meter times a meter, it's the usual meters squared, and 1/2 multiplied by 12 is the same as 12 divided by 2, which is equal to 6 meters squared, and that's the area of triangle 1. And triangle 2, we can say that the area this time is equal to 1/2. Now the base we have here is 9 centimeters. Notice the difference. In the last example the lengths were in meters, but this time we have centimeters. This doesn't change anything at all, only for the fact that when you give the final answer you have to write it in centimeters, because that's what the lengths are given in. So we can say that it's 1/2 times 9 centimeters times by the height, which is 5 centimeters, and that is equal to 1/2 times, well, we know that 9 times 5, well, we'll write 1/2, 9 times 5 is 45 centimeters squared. And if I can fit in room, we can know that 1/2 times 45 is the same as 45 divided by 2, which we can say is 22.5 centimeters squared, and that's the area of our second triangle. So now we're going to have a look at parallelograms and how we calculate the area of them. The formula itself is actually very similar to that of a rectangle, but the difference is when we multiply the base, which is this bottom horizontal surface here we mentioned before, the height isn't the length of the side here. The height, the same as the triangle's height when measuring that area, is the vertical distance between the top and the bottom of the shape. So instead of being the length of these lines, it's basically just, imagine we draw a line straight up, and the height is the vertical distance between the bottom surface and the top surface. It is not the length of this side here. Okay, so here we have an example where the base is 10 meters, the length of this side is 6 meters, and the height is 5 meters. So how do we calculate this? Well, we can say that the area is equal to the base, which is 10 meters, times by the height, which is 5 meters, and what that equals is 10 times 5, which is 50 meters squared. And the reason that I included this side in, this 6 meter side, is just to stop any confusion happening. So the only way, or the only things that we need to calculate the area of a parallelogram is the bottom distance here, known as the base, and the vertical distance from the top to the bottom surface, which is the height. That's all is needed to calculate this equation. Okay, moving on to kites. This is where calculating the area can be a little bit more tricky, but with a little bit of simplification of the shape, it's easily doable. As we can see here, we can divide a kite up into 4 different triangles, as we can see here, 1, 2, 3 and 4. And the unique thing about kites is that the shape is symmetrical about this red line down the middle. And what that means is this first triangle here, number 1, is symmetrical with number 2, and that means they have the same areas. And that can be said the same with triangle 3 and triangle 4. Both of them have the same areas. Therefore, all we need to calculate the area of a kite is if we can figure out the area of the top triangles, so for example number 1, and the bottom triangle number 3. And if we know the area of each of these 4 triangles, we can say that the area of the kite is the area of triangle 1, which we've called T1, plus T2, plus T3, and plus T4. Okay, so here we have an example with the lengths given, and as we said before, the way that we are going to calculate the area of this kite is by going through each of these 4 triangles that we've divided up and then adding them together using this formula. Okay, so beginning with triangle 1, we know that the height of the triangle is 5 meters because that's what's indicated here from this line up to the top corner. And we know that the base is 3 meters because from the diagram we can get that the total width of the kite is 6 meters, and we know that the shape is symmetrical about this red line. Therefore, the base of this triangle would be 6 divided by 2, which equals 3 meters. So we can say that the area of triangle 1 is a half times the base, which is 3 meters, and then times by the height, which is 5 meters. Therefore, T1 is equal to a half, and 3 times 5 is 15 meters squared, and therefore T1 is equal to, well, a half times 15 is the same as 15 divided by 2, which we can say is 7.5 meters squared. And therefore, if we know that the area of T1 is 7.5 meters squared, then the area of T2, this triangle that lies symmetrical to T1, must also be equal to 7.5 meters squared because the areas of these 2 triangles are the same. So since we know the area of T1 and T2, it's now time to move on to look at T3 and T4. And here we have the diagram of the triangle T3, and we've said that the height is 10 meters as we can get from the diagram, and the same from above. We know that this distance in here is 3 meters because the overall width of the kite is 6 meters, therefore that is half of that, which equals 3 meters. So we can say that T3 is equal to a half times the base, which in this case is 3, although it's not at the bottom. I mentioned that all that matters is it's the horizontal distance and it's perpendicular with the height. So the base in this case is 3 meters. And the height is 10 meters, which is the distance between the base and the opposite corner, the top of the triangle, which is 10 meters. Therefore, we can say that T3 is equal to a half, and we know that 3 meters by 10 meters is equal to 30 meters squared. Therefore, we can say that T3 is equal to a half times 30, or 30 divided by 2, which is equal to 15 metres squared. Therefore, we can say that if T3 is equal to 15 metres squared, then T4 must also be equal to 15 metres squared because they have the same area. And then finally, to calculate the area of the kite, we must add up the area of all 4 of these triangles. So we can say that the area is equal to 7.5, which is T1, add 7.5, which is T2, add 15, which is T3, and another 15, which is T4. And adding all of these up, that comes to an area of 45 metres squared. So to summarise the area of the kite, the way to calculate it is to split the kite into 4 different triangles by connecting the opposite corners and then calculating the area of one from the top and one from the bottom, and then the ones on the either side are equal because of this line of symmetry. Okay, so the last shape that we're going to look at is a trapezium. And I don't think we've looked at this before, but essentially what a trapezium is a 4-sided shape which has 2 sides that are opposite and parallel, and 2 other sides which are both different in length from one another. And the 2 sides that are parallel are labelled A and B within this example, and the height between them is just simply named H. And when we look at the equation, it may look quite complex at first, but all it's saying is the area of a trapezium is equal to a half multiplied by the sum of A and B, so A and B both added together, and then times by the height between them. There's a cheesy song that you can use to help you remember this formula a lot easier, which I'll include in the description below, and sometimes sort of rhythms and songs can help you easily memorise a formula instead of just trying to remember it bit by bit in the written form, so you should check that out if you struggle to remember the equation. But let's move on to look at an example of this. So here we have an example where the parallel sides are 10 metres and 6 metres respectively, which in the equation is A and B, and H, the height in this example, is 4 metres. So if we were to write this out, we can say that the area is a half multiplied by A plus B, which is 6 plus 10, and then we said the height is 4, therefore A is equal to half, and 6 add 10 is 16 times by 4, and then if we say a half times 16 is the same as 16 divided by 2, which is 8 times 4, and therefore the area of the trapezium is 8 times 4, which is 32, and we're in metres, so it's metres squared. So to recap this lesson, we said that 2D shapes are those which are flat on paper and have both a length and a height. So for example, circles, squares, triangles, things like that are all 2D shapes. We said the area of 2D shapes can be measured in either metres squared, centimetres squared, or kilometres squared, all depending on the scale of the problem. We said that the area of a square is equal to the length of one side all squared. And for a rectangle, the area is the width of one side times by the height. And the area of a triangle is a half times the base of the triangle times by the vertical height. The area of a parallelogram is the length of the base multiplied by the vertical height. To calculate the area of a kite, we can divide the shape into 4 different triangles and then add them all together. So we have the area of triangle 1 plus triangle 2 plus 3 plus 4. And then finally we said that the area of a trapezium is equal to half of the sum of the parallel sides being A and B, and then we multiply it by the height h between them. Thanks again for watching. I hope this video has been helpful to you. If you have any questions, feel free to drop it down below and I'll get back to you as soon as I can. But in the meantime, I'll see you in the next video.